Hello everyone, welcome back. Hope you all are doing great. Guys, I have some requests from my subscribers to make one video on IPsec. So today we are going to understand IPsec in this video. I will cover IPsec in two parts. In part 1, I will discuss theory parts, and in part 2 I will show you the configuration, how to configure it. So you can see I have this topology. In this topology I am going to configure IPsec. But first of all, we will discuss theory part. In theory, you will learn like what is authentication, what is data integrity, what is confidentiality, what is anti-replay, because these are the parameters offered by IPsec. So to understand IPsec, first you have to understand these parameters. Then you also need to understand some basic terms of security, because IPsec is a part of security, right? Like Diffie-Hellman group, how it's working, what do you mean by lifetime, what do you mean by keys, right? So whatever things we have in theory, first we will cover that, and then we will see how we can configure it on Cisco routers. If you want to know how to configure IPsec on ASA firewall, I have already video on channel. You can check that video, right? To learn how to configure IPsec on ASA firewall. Today we are going to configure IPsec on Cisco routers. So first of all, guys, try to understand why we need IPsec. So see, in this topology I have two branches, or you can say I have two sides. Let's say this is side 1, and this is side 2, right? As you know, by default two sides cannot communicate with each other through public network, right? Because side 1 and side 2, let's say this side is in India and this side is in, let's say, US, right? Both sides are connected together with the help of ISP, and ISP is a public network, right? So as you know, by default these two sides cannot communicate with each other over public network. So to make communication possible between side 1 and side 2, what you need to do, you need to create one virtual private network over public network. That is VPN. With the help of VPN, we can make communication possible between side 1 and side 2, between multiple branches over public network. So let's say here I have created one virtual private network over public network. Let's say this is my tunnel, right? I have created this tunnel, right? On router number 1, interface tunnel 10, on router number 2 also interface tunnel 10, and on the tunnel interface I am running this network, right? Now these two devices can communicate with each other. You can configure GRE tunnel, right? So through GRE tunnel these two sides can communicate with each other. But problem is what? Problem is GRE is not secure, right? GRE is what? This VPN, virtual private network, is what? It is a logical connection, right? It is a logical connection. Even you are forwarding traffic through the VPN tunnel, but your traffic will flow on this link, right? On the public network, on the ISP network. And as you know, ISP network is not secure. There are lots of bad people, right? They can capture your data, they can attack in your network, right? They can see your data. So public network is not secure, and I cannot forward my critical data through my GRE tunnel. My GRE tunnel is because not secure, right? Anyone can capture the link or they can read the data. Getting my point? So if you are using VPN or GRE tunnel to make communication possible between two private sites over public network, that means you are not using a secure path, right? Anyone can read your data. Let's say on the tunnel interface you are running what? EIGRP protocol, right? So EIGRP is sending hello message. So if I will capture the link, I can read your hello message, right? And whatever data you are forwarding through the tunnel interface, that is not secure on public network. So to secure the data on this tunnel, on the GRE tunnel over the VPN, we are using what? IPsec. IPsec. So if someone will ask you what is IPsec, so IPsec is nothing but, we can say IPsec is a protocol suite. It is a group of protocol like OSI model. What is OSI model, or what is TCP/IP model? TCP/IP model. It is not a protocol. It is a protocol. Protocol suite means group of protocol. In the same way, IPsec is also group of protocol, right, which is used to secure, or which is used to establish a secure tunnel between two point, or you can say which is used to establish a secure connection between two private network over public network. So GRE tunnel is what? GRE tunnel is used to, establish a logical connection, a virtual connection between 2 points over public network. Definition of both IPsec and GRE tunnel is same, but difference is GRE is not secure, IPsec is secure. So IPsec is used to establish a secure connection over the public network between 2 points, you can say. Getting my point, guys? So IPsec, if someone will ask you what is IPsec, IPsec is a protocol suite which is used to establish a secure connection between 2 points over public network. Now, IPsec offers multiple parameters. Let me discuss about that parameters first, right? So let me do one thing. Let me open my Paint, and here IPsec offers. See, IPsec offers these all points, these all parameters. First, it offers authentication. Then it offer data integrity. Third, it provide integrity. Third, it provide confidentiality. Fourth, it provide anti-replay. Getting my point? So IPsec provide these 4 parameters. Guys, now what is authentication? What do you mean by authentication? So in simple word, what you can say, because what I am assuming, you are not security engineer, I'm assuming you are routing switching engineer, right? So how I will make you understand IPsec? Okay, so see, in simple word, what we can say, authentication is a process of verifying a user, or you can say verifying a device before sending the data or before allowing the access of device. Let's say you want to access one router through telnet, right? So authentication over here is what? Device will authenticate you first. It will ask you for username, it will ask you for password. That is what authentication, right? So authentication is nothing but what we can say, who are you, right? This is like who are you. Authenticate the user. Then data integrity. What do you mean by data integrity? Data integrity is nothing but you can say trustworthy of data. Means data should not be modified by a unauthorized user. No one can change the data, right? Let's say if you are sending something over here through this GRE tunnel. For now, let's say this is GRE tunnel, right? So if here is one user and here is one user, these two users want to communicate with each other. Let's say this is PC1, this is PC2. So if PC1 will send one data, and data is, let's say, hello, right? It will send to router will send to R2. Now it will send to GRE tunnel. GRE tunnel is not secure. Let's say here we have one attacker. Here there is one attacker. What if this attacker will change the data? If this attacker will change the data from hello to bye. So now your data is what? Bye, right? And then it will forward to router number 2. Now router 2 will forward it to PC2, because source IP, destination IP, everything is same. So this attacker have only changed the data, the payload. So data was hello, but attacker have changed it to bye. So PC2 will get what from PC1? Bye, not hello, right? So this is, guys, integrity. Integrity means no one should be able to modify your data. No one should be able to change your data. So IPsec will provide you this feature that no one on the public network can modify your data. Getting my point? Now hope it is clear. Hope it is clear to you, like what is integrity, right? And we will see how we can achieve integrity. Just I am giving you one overview. Like IPsec offer these parameters and what is the meaning of these parameters. So means data, we can say what data should not be modified, right? And then confidentiality. What is the meaning of confidentiality? Confidentiality means, you know what, only authorized user should be able to read my data. Only authorized user should be able to read my data. Let's say over here, if the attacker have capture my data, but this attacker should not be able to read the data, right? Actual data is what? Hello. So this attacker, now if you are sending this hello data on the GRE tunnel, through GRE tunnel, attacker can read it by capturing the link. But if you will configure IPsec will provide you what service? Confidentiality. Means this attacker will be not able to read the data. This attacker cannot read the data, right? So confidentiality means nothing but you can say, it means nothing but you can say what? Only authorized person can read the data. What we can say? Only authorized person can read the data, right? And then what is anti-replay? So guys, see what is anti-replay. Let me give you one example to make you understand anti-replay. Let's say here we have one branch of, let's say, bank. This is branch of a bank branch, let's say bank branch, and this is headquarter. This is headquarter of that bank. From the branch office, let's say we are sending $100. $100 from branch office to headquarter. I am sending what? $100. And let's say there is one attacker in between branch office and headquarter. There is one attacker. So this attacker cannot read the data, cannot read this message. Because of what? Because of confidentiality. Because here, let's say we are running what? IPsec between these two branches, branch office and headquarter, right? So because of confidentiality, this attacker cannot read this message. Because of data integrity, this attacker cannot modify the amount, like they cannot change the amount over here, $100 to $200, right? This attacker is not able to modify the data. Because of what? Because of data integrity. So in the IPsec we have data integrity, so this attacker is not able to modify the data. This attacker cannot change the amount, right? In the same way, this attacker cannot read the data because of confidentiality. This attacker cannot spoof the data because of authentication, right? This attacker cannot spoof the data because of authentication. But what this attacker can do? This attacker can make a duplicate copy of it. Attacker can make a duplicate copy of it, and then attacker will retransmit that duplicate copy to headquarter, right? Then what will happen, guys? Then transaction will happen twice. Transaction will happen twice. So if this attacker will make a copy of this data 100 times and it will forward to headquarter 100 times, then transaction will happen 100 times. To avoid this type of attack, we come up with this feature, anti-replay feature, right? We come up with anti-replay feature, or you can say to solve this problem, we come up with anti-replay features, right? Or concept. What anti-replay will do? Anti-replay, it will solve it by adding a sequence number to every message that is sent to server or headquarter, that is sent to headquarter. It will add one sequence number, right? What I am saying, guys, it will solve this problem by adding a sequence number to every message that it will forward to headquarter. So when the server will receive this message, it is going to log that it is already received. Let's say here we have one sequence number that is 10. So this headquarter is going to maintain one log, right? It will have one entry that I have already received this packet with sequence number what, 10. So I will not receive this packet with same sequence number again. So if this attacker will duplicate it, right, there will be what sequence number, guys, 10, right? So but the headquarter router will not receive same packet with same sequence number, right? So we can avoid this type of attack with the help of anti-replay. And IPsec offers these features as well: anti-replay, confidentiality, data integrity, and authentication. Now hope it is clear to you. Let's understand same example over here, right? So let's say here I have one PC and I have one server over here, right? So if this PC is going to send $100 to this server, let's say again this is bank branch and this is headquarter. So if this branch office user is going to send $100 to the headquarter server, $100, here we have one attacker. So guys, this attacker can not modify the amount, this attacker cannot spoof the identity, this attacker can not read the data, but this attacker can duplicate it, right? But as we are running IPsec, so IPsec offer what? Confidentiality, authentication, integrity, as well as anti-replay, right? So this attacker cannot duplicate it. This attacker cannot duplicate it. So hope now it's clear to you what is authentication, what is integrity, what is confidentiality, and anti-replay. Anti-replay means no one can duplicate the packet. No one can duplicate the packet, right? So how we will achieve anti-replay? With the help of sequence number. Okay, now let's understand some basic terms of security like encryption. Let me discuss some basic terms of security first to make you understand IPsec. So first term is encryption. Encryption, guys, what do you mean by encryption? Encryption means converting plain text into cipher text, right? Let's say my actual data is what, 1 to 3. So this is what plain text, or my actual data is, let's say, ABC. So this is what plain text. So I will convert it into cipher text. Let's say cipher text is 1, 2, 3. So I have used one algorithm that A will be encrypted into 1, B will be encrypted into 2, and C will be encrypted into 3, right? So this is encryption. This is my plain text and this is my cipher text, right? Now for the encryption, again we have multiple algorithms, right? So we will understand that algorithms, what algorithms we have for the encryption. Okay, so hope it is clear to you what is encryption. Now we have two types of encryption. First one is bit by bit encryption, and second one is what happened? Second one is block by block encryption. Guys, if I will talk about bit by bit encryption, so bit by bit encryption is the method to encrypt each and every bit of data, right? To encrypt each bit of data, right? One bit at a single time. So let's say you have a data of 100 bits. So it will run how many times encryption algorithm? 100 times. Getting my point? Generally we are not using it bit by bit encryption. Bit by bit encryption means one bit at single time. For 100 bits we need to run 100 times encryption algorithm, right? So here in bit by bit our CPU utilization will be high, right? High CPU is required, high CPU, right? But generally, you know, we are not using it, right? In Cisco devices and in the enterprises network or in ISP network, in large network also, in a small network also, we are not using bit by bit encryption. This is for army, right? For the military purpose, right? For the very critical data of governments, army data, right? Those type of data. So for bit by bit encryption, actually, you know, companies are designing a specific hardware, right? Like whatever routers and switches, firewall we are using, right? Those all devices support what? Block by block encryption only, not bit by bit encryption. Getting my point? So we are going to understand block by block encryption. In block by block encryption, what will happen? My encryption algorithm will encrypt the data by block to block. Means, you know, first it will select one block, maybe block of 56 bits. Let's say it have select one block of 56 bits. So it will encrypt first 56 bits of data by running algorithm, and then again on the next data it will run encryption algorithm. Let's say I have one data of 100 bits whose size is 100 bits. So how many time my device is going to run? How many times my device is going to run encryption algorithm over here? 2 times. In first time it will encrypt first 56 bits data, and in the second time it will encrypt around, you know, how much data? 44. Yes, 44 bits of data, right? So in block to block encryption, my device will run encryption algorithm 2 times, right? But again, if you will encrypt 100 bits of data by bit encryption method, then device will run 100 time encryption algorithm. Okay, so hope it is clear to you. And generally we are using block to block encryption algorithm, right? We are using block to block encryption algorithm. Okay, in the enterprise network, enterprise, or you can say what? ISP. Fine guys. Now if I will talk about the algorithms of encryption, algorithm, so we have multiple algorithms for encryption, right? Like DS, then we have what? 3DS, then we have AES, and then RC6 and many more. Leave it, right? In IPsec generally we are using what? AES and 3DS. AES and 3DS, and today also in the configuration part we are going to use any one from these 3 algorithms, right, for the encryption. So IPsec provide encryption features, but you have to configure the algorithm, that which algorithm you want to use for encryption. You have to define the algorithm, that which algorithm you want to use for encryption. Getting my point? Guys, DS stand for data encryption standard. Data encryption standard. And 3DS stand for thrice data encryption standard. And AES stand for advanced encryption standard, right? These all are encryption algorithm. Let's say my actual data is what? ABC, right? And I am using what? AES for the encryption. My data is ABC. So I am running which algorithm? DES. So DES will encrypt it to, let's say, XYZ, right? And guys, what is the difference between DS and 3DS? So both are same, but if you are running DS algorithm, so it will run the algorithm once to encrypt the data. If you are running 3DS algorithm, so it will run same algorithm thrice. It will run same algorithm thrice. Let's say in this topology, let's say here I am going to send one data. My data is ABC, right? And I am using algorithm what? DES to encrypt it. Through this algorithm, I have encrypted it into 1, 2, 3, let's say, right? And after that, I will share it through public network. So there is one attacker. So if this attacker is let's say trying to decrypt the data, and this attacker is able to decrypt the data, but this attacker is taking how much time? 2 hours to decrypt the data, to find the key, right? Actually, DS algorithm will use one key to decrypt ABC into 1, 2, 3, right? And attacker don't know about that key, that DS is using what key to encrypt ABC into 1, 2, 3. Let's say it is using key number what? 10, right? So this 10 is simple, but in real time, when you will configure, you can check, right? It will pick very complicated key, right? So let's say attacker is taking 2 hours to know the key to decrypt the data, right? So after 2 hours, it can decrypt the data, but we are changing the key after every 1 hour. Let's say after every 1 hour, we are changing the key, this key number. Let's say after 1 hour, this key number will become what? 20. So now even attacker can decrypt it after 2 hours, but it will take actually 2 hours to know the key, what key DS is using to encrypt the data, right? So but after 1 hour, we are changing the key, so this attacker cannot decrypt my data, right? But still, guys, see, this is secure, but to make it more secure, we come up with 3DS, right? In 3DS, what will happen? First, it will encrypt ABC into 1, 2, 3, let's say. Then again, it will run a DS algorithm. Maybe here it have encrypted to XYZ. Again, it will run DS algorithm. This time, let's say it is encrypting to PQR, right? And then it will forward it to public network. So this time, attacker needs how much time, guys? 6 hours, right? Because here we have run 3 times DS algorithm. So this is only difference between DS and 3DS. 3DS is more secure than DES. Both are encryption algorithm. You can use this one also. You can use this one also. 3DS also. But which one is more secure? 3DS, right? Again, if I will compare 3DS to ES, advanced encryption standard. So ES is more secure than 3DS. So that's why generally we are using this one, this encryption algorithm, right? So when I will configure IPsec over here, maybe I will use AES encryption algorithm for encryption. Now hope it is clear to you, like what is encryption. Now let's move further. Next thing. So guys, with the help of encryption, what we are achieving? Confidentiality, right? We are encrypting the data, means only authorized person can read my data. No one can read my data, right? Attacker cannot read my data. So with the help of encryption, we are achieving what? We are achieving confidentiality, right? So I have achieved confidentiality in IPsec with the help of what? Encryption. I will use any one encryption algorithm over here to encrypt my data, So hope it is clear to you now. Now the next thing is what? I need to achieve integrity also. Integrity. How I will achieve integrity? Integrity means only authorized user can change the data, can modify the data. Means, let's say over here, in the same scenario, if I am sending one data over here, hello, from this network to this network through public network, right? So here, let's say we have one user who is receiving this data. This user should be able to, or router 2 should be able to know that data is modified or not. Let's say there is one attacker. So this attacker should not be able to modify the data. Right? This is integrity. So how I will achieve integrity? With the help of hashing. With the help of hashing, we will achieve what? Integrity. We will achieve integrity. How we will achieve integrity? With the help of hashing? Guys, hashing is exactly similar like, remember CRC in the Ethernet header. in the Ethernet header. Let's say we have two computers, PC1, PC2. If PC2 want to send some data hello to PC2, at Ethernet header we will add one, we have one field, that is FCS. Inside the FCS field we will put one hash value. We will put one hash value. Let's say hash value is what? XYZ. I have created this hash value with the help of what? Data. Here my actual data is what? Hello, right? So when computer B will receive the data, computer B will also calculate one hash value with the help of this data, right? And it will get same hash value XYZ. But let's say on the link, if someone will modify the data from hello to hi, then PC2 is going to calculate hash value with the help of data. So it will run the algorithm. In the algorithm, this time it will put what data? Hi, right? So definitely it will get different hash value. Let's say it is getting ABC, right? Once it will get ABC hash value, it will compare their hash value, and the hash value which is coming in the frame is different. It will drop the data. That means data is modified over link or during the transmission, right? In the same way over here also, in my scenario, whenever this PC is going to forward data to this PC, what router 1 will do? Router 1 will add one, because here we are running IPsec. Router 1 is going to add one hash value with data. Let's say my data is hello, and it will add one hash value over here. Let's say hash value is what? ABC. In the same way, router 2 is also going to calculate hash value, right? If hash value will match, then only router 2 will accept it, otherwise it will discard it, right? So how we will achieve integrity? With the help of hashing. Hashing means just calculate one hash value and mapped it with data. So let's understand now hashing. So what we can say? What is hashing? If someone will ask you what is hashing, what will be your answer, guys? So I can say hashing is, what we can say, it is a technique of mapping key or hash value. Technique to map key or value with data. Technique to map key or values with data, hash value with the data or into the data, by using what? Hash algorithm. By using hash algorithm, right? And we have again multiple hashing algorithm, like we have MD5 hashing algorithm, we have SA, then we have what? SA 512, then we have what? SA 256. These all are algorithms that we can use for hashing. See, if you will go to Google and you can check it. Go, let me take you to Google over here. In the Google, what I can say, MD5 calculator. Let me search MD5 calculator over here. See, this is MD5 calculator. Okay. Now, if I will put over here some data, let's say data is, let me copy some paragraph. Let me say these are my data. Okay, just I'm taking one example, so I'm going to copy this text. So this is my data. If I will put this data into this algorithm, it will calculate one hash value for me. See, this is the hash value, right? And I will add this hash value with my actual data. Now if I will change anything in data, my hash value will be changed. Let's say I'm removing this dot. See, if I will remove this dot, see, the hash value is changing. If I'm adding dot, hash value is changing, right? If I'm adding any key over here, hash value is changing, right? So this is how MD5 algorithm is calculating what? Hash value, right? In the same way, we have what? SAHA algorithm. You can check how SAHA is going to calculate hash value. So these all algorithms are used to calculate hash value, and we will map this hash value with actual data, right? To achieve integrity, right? So in the configuration, again, we can use MD5, we can use SAHA, we can use SAHA 512, any algorithm I can use for hashing. Getting my point? So before sending the data, sender will calculate one hash value, and then it will map it with the data, right? Map it with the data and then transmit it to the tunnel. When receiver machine will receive the data, again it will calculate the hash value. If hash value will match, then it will accept. If hash value will not match, then receiver machine will discard it. Getting my point? Now hope this is clear to you. Hashing, right? Now guys, what is the difference between SA 512 and SA 256? And we have SA 1 as well. Here I can say SA 1, right? So difference is, see, if I will talk about MD5, so MD5 algorithm adds 128 bits hash value. 128 bits has value. If I will talk about SA1, so SA1 add I think 160 bits has value, right? So SA1 is more secure than MD5, because MD5 is going to add 128 bits has value and SA1 is going to add 160 bits has value, right? In the same way, SA2 add I think 224 bits has value, and you can check this information. This is not important. This is not important. Now guys, see, in this scenario, let's say I'm going to form a IPsec tunnel between R1 and R2, right? I'm going to configure IPsec tunnel between R1 and R2. So here, let's say I'm using encryption algorithm. What? I'm using encryption algorithm 3DS. I'm using MD5 for hashing, right? And if I will forward these two algorithms on the public network, what will happen? Attacker can also knows my algorithm, what algorithm I am using for encryption, what algorithm I am using for MD5. And everyone know, right, how 3DS work, how MD5 works, right? Because everything is available on Google. As I shown you in the Google, right? You can put the data, you can calculate the hash value. You can put the data and you can calculate the hash value. Right? In the same way, attacker can also put the data in that algorithm and they can calculate the hash value. Right? Attacker can also decrypt the data. So actually, you know what we need? We need a way to way to send this algorithm to router number 2 securely, right? So that attacker can not read this information. Attacker can not knows my algorithm, right? So we need a secure way to share this algorithm to router number 2. So that's why we come up with what? Diffie-Hellman group. Diffie-Hellman group. In short, we are saying DH group. So DH or Diffie-Hellman is used to generate a symmetric key over unsecure channel. What you can say? Let me write over here. Diffie-Hellman is used guys, you can check the spelling, right? I'm not sure what the spelling. Diffie-Hellman is used to generate a symmetric key over a unsecure channel. Right? Now if you are thinking what is key and what is symmetric key, right? So guys, see, there are two types of key. One is symmetric key, another one is asymmetric key. symmetric key and a symmetric, what happened here, symmetric key. Symmetric key means, symmetric means same key to encrypt, same key to decrypt. Let's say I have one lock. I have one lock. My drawing is not well, but let me try. I have one lock over here like this. Right? I can use this lock to lock my door. Right? And to lock it and to unlock it, I need what? One key. I need one key over here. Right? So let's say this is my key. To unlock the, to lock and unlock, I am using what? Same key. To lock and unlock, I am using same key. So this is what? This is symmetric key. Symmetric key means same key to encrypt the data, same key to decrypt the data. Asymmetric key means one key to encrypt the data and other key to decrypt the data. Or you can say one key to encrypt the data and one key to decrypt the data. Right? So Diffie-Hellman is used to generate a symmetric key over unsecure channel. And see guys, what is key? So let's say you want to encrypt one data. Your data is, let's say, ABC. Your data is what? ABC. So you need one key over here to encrypt it. You have algorithm, but again you need what? Key. Then only you can encrypt it. And key can be symmetric, asymmetric, and hope it is clear to you now what is symmetric and asymmetric. So Diffie-Hellman DH is used to generate symmetric key over a unsecure channel. So see first how Diffie-Hellman work. So guys, let's say here I have router 1. Right? Between R1 and R2 we have ISP. This is router 1. This is router 2. So what I am saying here, I have encryption algorithm, hashing algorithm. Encryption algorithm is, let's say, what? 3DS. Right? Hashing algorithm is what? Let's say MD5. MD5. I want to share it to R2, right? To establish a tunnel. But if I will share it directly to router number 2, anyone can read it on internet. So that's why we come up with DH group. DH group. Now what will happen in DH group? See, on both router we will define one number, group number, right? Let's say here I have defined group 5 on router number 1. On router number 2 also you have to define same group. On router number 2 also I have defined what? Group 5. See, now what these two router will do? Router 1 is going to, if router 1 will share this number to router number 2, attacker will capture it. Attacker can knows the number, right? Attacker can knows the number when router 1 will send to router 2 and router 2 will share to router number 1. So this router R1 and R2, these two routers want to exchange a symmetric key that should be unknown for attacker. That should be unknown for attacker, right? So to achieve this, to exchange a symmetric key between R1 and R2, right, our unsecure channel, it is using what? DH group. How DH group works? See, both router will pick a random number. Let's say router 1 have pick one random number is what? Let's say 10. And router 2 have pick one random number what? Let's say 15. Right? Now both routers are going to add their random number with the predefined number which you have defined. Let's say here I have defined what? 5. Right? So 5 plus 10. Here it will become what? 15. Here it will become what? 20. Right? So router 2 on router number 2 predefined number is 5. It have pick one random number, that is 15. On router number 1, predefined number is same 5, and it have pick one random number, that is 10, and both have added it, right? And now router 1 is going to share this number to router number 2, and router 2 is going to share this number to router number 1. Again, if there is attacker, so attacker will get number what? 15 and 20, right? Attacker will get number 15 and 20, right? See guys, these router are going to use this number to encrypt the data, right? This is very important, right? This is ISP, not secure network. So attacker will get number 15 and 20. Now what R1 will do, R1 will add their random number again with the number which router 1 have received from router 2. So router 1 have received what number from router number 2? It have received which number? 20, right? And router 2 have received what number from router number 1 now? 15, right? Attacker have also knowledge about these two number, right? But see how both routers are going to pick one number, right? And that will be unknown for attacker. Now what these two router will do, these two router will add their again random number in the number received by their peer. Let's say like router 1 have received what number from router number 2? 20. It will add their random number over here, right? Their random number is 15. It will get what number? 35, right? In the same way, router 2 have received what number from router number 1 from their peer? 15. And what is their random number? 15. So it will add their random number. Oh, there is some mistake. Let me check. 20, and it will add here what? Their random number. Their random number is not 15. Their random number is 10. Router 1 random number is 10. This is random number, random number, and defined number, predefined number. This is random number. This is predefined number, right? So it will add what? Their random number 10 over here. So it will get value what? 30. In the same way, router 2 received number from router number 1 is 15, and their random number is 15. It will also get what number? 13, right? And now guys, these routers are never going to share this key, this number, right, on the unsecure network, on the ISP, on the tunnel, right? These routers are not going to share this value. So this is how DH group work, right? This is how this DH group work. So with the help of DH group or Diffie-Hellman group algorithm, what we achieved, we exchange a symmetric key. Symmetric key, why I'm saying symmetric key? Because both side number is same. We have exchanged a symmetric key over unsecure channel, and this number is now unknown for attacker, right? So now I will use this number to encrypt my algorithms. I will use this number to encrypt my algorithms, or you can say policies, right? Or you can say security association, SA. Parameters, policies, association, these are nothing but your encryption algorithm, you can say what? Encryption algorithm, or you can say what? Hashing algorithm. These are what? Parameters or policies. So hope this is clear to you, like how Diffie-Hellman is going to work. Now guys, again, what is IPsec? IPsec is a protocol suites which offer confidentiality, integrity, authentication, and anti-replay, right? Authentication, how we will achieve authentication? With the help of pre-shared, right? We will understand that also, right? So guys, now I want to discuss the first protocol which comes under IPsec. As I am telling you again and again, IPsec is a group of protocol. So the first protocol which comes under IPsec is ISAKMP. ISAKMP. ISAKMP stand for Internet Security Association Key Management Protocol. Internet Security Association Key Management Protocol, right? So this is the first protocol which comes under IPsec, right? And ISAKMP is the protocol which tell us how works will be done, काम कैसे होगा, right? And ISAKMP uses a protocol called IKE protocol. IKE, right? IKE protocol. In IKE, we have two version 1 and version 2. We have two version 1 and version 2. Today we are going to understand version 1. Guys, in version 1 we have two modes. First one is, we have two modes. First one is main mode, and second one is quick mode. If you are thinking, Praphul, what we are learning, what you are saying, IKE, ISAKMP, version 1, main mode, quick mode. So what I am saying, brother, IPsec is a protocol suite, means it is a group of protocol, and the first protocol which comes under IPsec is ISAKMP. And ISAKMP is a protocol which is used to share, which is used to share policies, which is used to negotiate policies. ISAKMP is responsible to carry your encryption algorithm, your hashing algorithm, these algorithm. How? With the help of a protocol. That protocol is called IKE. ISAKMP is going to use this protocol, IKE protocol, right? So ISAKMP protocol is responsible to carry your policies, like what on router number 1, let's say you are using encryption algorithm ES, right? You are using hashing MD5, right? So ISAKMP protocol will carry this information. ISAKMP uses UDP port number 500, right? And ISAKMP uses which protocol? IKE protocol, right? Guys, again, if you are getting confused, to make you understand like how IKE protocol works, version 1, version 2, we need lots of time, right? Lots of classes. So definitely then you have to either go for live training, or what I can do, I can create one separate playlist for IPsec VPN on my channel, right? Here we cannot discuss everything. Just I'm giving you one overview, you can say, right? So that you can configure IPsec in real time if you are a network engineer, or you can answer to interviewer if you are preparing for interview. So IPsec is a protocol suite, and the first protocol which comes under IPsec is ISAKMP. ISAKMP is used to carry my policies, right, or a security association. And ISAKMP uses which protocol? IKE protocol. In IKE we have two versions, version 1 and version 2. Today we are going to understand version 1. In version 1 we have two mode, main mode and quick mode. See guys, if I will share these algorithm directly to router number 2, right? Anyone can read this information. Anyone can know what algorithm R1 is going to use. Yes, MD5. Oh, I know how this algorithm works. I will read the data. I can establish a connection with router number 1. Let's say there is one X router over here, right? So what if X router will spoof their address, if they will hide their identity, if this X router will tell to R1 that I am router number 2, right? Please establish a connection with me, right? So we have authentication for it. So X router cannot establish a connection for router number 2. But first of all, we need to encrypt this information. And to encrypt this information, we need a key. We need a key. And that key should be unknown for attacker. So I have used what? I have used DH, means Diffie-Hellman group algorithm, to exchange a symmetric key between R1 and R2. With the help of that key, I will encrypt this information, right? So attacker don't have that key. So attacker cannot decrypt it. Attacker can never knows what algorithm I am using over here, right? So to not share this algorithm directly, we divide IPsec into two phases, you can say, right? To not share this information directly, we divide IPsec into two phases, phase 1 and phase 2. In phase 1 we will secure the path. Let's say this is my tunnel. So in phase 1, first I will secure this path, because if my path is not secure and then I am sending my algorithms over here, my policies over here, anyone can read that. So first I will secure my path and then I will secure my data. So phase 1 is used to secure the data, and phase 1 works with main mode and phase 2 works with quick mode. Phase 1 works with main mode, phase 2 works with quick mode, right? We have some messages in main mode, we have some messages in quick mode. So we will use phase 1 to secure the path, we will use phase 2 to secure the data, because until and unless my path is not secure, my parameters are not secure, my policies are not secure. Parameters, policies means what? The algorithms which I am using for encryption, hashing, right? So first I'm going to secure my path, then I will secure my data. Okay, so understand one more terms here, that is security association. Then again I will come on ISAKMP protocol. Security association, SA. So guys, it consists of authentication, algorithm, encryption algo, lifetime, group means DH group, Diffie-Hellman group, and hashing, right? Combination of these parameters or policies are known as security association, So see, I have router number 1, let's say this router is sender and this router is receiver, right? So here I am using authentication pre-shared. Now if you are not familiar with pre-shared, so let me tell you what is pre-shared first. So guys, pre-shared key is a string which is used to authenticate the PR, right? We will use pre-shared key to authenticate the PR. Like I am establishing a tunnel with genuine router or not, with authorized device or not, right? For that, so let's say I am using again for authentication we have multiple option, but if you are using pre-share method, manually you have to configure a key on both router. Let's say here I am running keyword Cisco, here also I am running keyword Cisco, right? So on both router pre-shared key is same and it should be same, then only tunnel will come up between R1 and R2. So let's say my authentication is pre-shared, my encryption is let's say AES, hashing is MD5, then my lifetime is let's say 1000, and group is let's say 1, for example, right? So if I will share this information to router number 2, and you have to do same configuration on router number 2 also, then only tunnel will come up. So when I will share this information, I want to form a tunnel with you. What this information is saying, actually router 1 is sending this information to router number 2 and telling I want to form a tunnel with you, and these are my policies, but attacker can also get this information. That's why what we have Diffie-Hellman. With the help of Diffie-Hellman, we have one key. I will use that key to encrypt this data, right? So now I have encrypted the data and then I am sending it to router number 2, so no one can read it. So now hope you have no basic idea about the IPsec. So if someone will ask you what is IPsec, so what you will say? IPsec is a protocol suite which is used to establish a secure tunnel between two points over unsecured channel over public network. And the first protocols which come under IPsec is ISAKMP. ISAKMP stands for Internet Security Association Key Management Protocol. ISAKMP uses UDP port number 500, which uses UDP port number 500. ISAKMP is, transport to carry algorithms. What you can say? ISAKMP is a transport to carry algorithms or policies or security association, right? So ISAKMP is a transport which is used to carry my policies, my security association, my parameters like encryption, hashing, authentication, right? So these all information will be carried by ISAKMP, right? So here we will have ISAKMP header, UDP port number 500. Source port will be also 5, destination port will be also 500. Then we will have what? IP header. Then what we will have? Data link layer header, right? And then R1 will forward it to router number 2. ISAKMP, we can use TCP port number 10,000 also, right? But for that again you have to run one command. And guys, again in VPN we have multiple types of VPN like IPsec and SSL VPN. In IPsec again we have multiple types of VPN: side to side VPN, remote VPN, DM VPN, get VPN, right? So now we are learning what? Only side to side VPN. And if you are not good enough with in security, so maybe these terms are complicated for you, but day by day when you will involve yourself in security, these all terms will become easy for you, right? So now question is how to configure IPsec. So see, first command, in the global configure mode you will run this command: crypto means cryptography means these features, guys, like encryption. I'm going to use encryption, hashing, authentication, right? Whenever you want to configure security feature, you have to configure it under cryptography. So whatever security policy you will configure on router, you will configure under cryptography. So that's why first command will be crypto. After that, what protocol I'm using? ISAKMP over here, right? ISAKMP. So crypto, ISAKMP. After that, I will create one policy over here, policy, and then policy number, right? So let's say policy number is 1, right? You can use any policy number. Policy number is locally significant. We can use same as well between two routers and different as well between two routers, but lower value will be always preferred, right? So let's say you have created 2 number of policies. Why we have policy number? Because we can create more than one policies on router. So if you are creating 2 policy, let's say policy 10 and policy 20. So first of all, router will check policy parameters inside policy number 10. Then it will check parameters inside policy number 20. Don't worry, I'm going to make you understand this also. Then we will define encryption protocol. What encryption protocol I am using over here? So let's say I'm using what? 3DS. Then I will define what hashing algorithm I am using over here. So let's say I'm using hashing algorithm what? MD5. Then we will define what authentication method we are using. Authentication means what authentication method I am using to authenticate the peer so that no other device can establish a tunnel. So authentication is, let's say, pre-shared, right? Then we will define group. DH group, Diffie-Hellman group. So let's say group is 5. Again we have multiple group. I will show you while configuration 1, 2 and 5. Higher number is more secure. Then we will define what? Lifetime. Let's say 10,000 or any number you can configure here. Let's say 3600. So what I did here, under the cryptography, I've configured ISAKMP protocol. I have created one policy. Policy number is 10, or let's say policy number is 1. Then I have defined the encryption algorithm, hashing algorithm. I have defined the authentication method. I have defined the group number. I have defined the lifetime. Lifetime is what? Lifetime is after how much time it will refresh the key, right? So let's say if here I am defining 1000. So after 1000 seconds it will refresh the key. It will change the key. If you will define 24 hours, means after every 24 hours it will refresh the key, right? In the same way, I have to do same configuration on router number 2 also, right? This side also. Getting my point? Here, let's say we are not using encryption 3DS. Here we are using encryption DES. Tunnel will not come up. Because on router number 2, this is my R1. This is R1 and this is R2. On router number 2, I am using encryption algorithm what? DS. On router number 1, I am using encryption algorithm what? 3DS. Means router 1 support encryption 3DS. Router 2 support encryption what? DS. Right? So your tunnel will not come up here. Right? So on router number 2, what you can do? You can create one more policies. Right? Maybe on router number 2, let's say we have multiple policies. Policy 1, policy 1. Under the policy 1, encryption algorithm is, let's say what? DS. Then we have, let's say, policy 2. Under policy 2, encryption algorithm is what? Let's say what? 3DS. Then we have policy, let's say 3. And under the policy 3, encryption algorithm is what? Let's say ES. Right? So when router 1 will send this parameter to router number 2, right? Router 2 will check first which policy. Router 2 will check first policy number 1. The lower value is always preferred, this policy. In this policy, I am using encryption what? DS. But in the packet which I am receiving from router number 1, encryption is what? 3DS. Then router 2 is going to check this policy. Right? In this policy, encryption algorithm is what? 3DS. So it has matched. Now it will check hashing, authentication, group, and lifetime. You can ignore lifetime as well. Minimum value will be negotiated. Right? So on router number 2 will start this. Will use this policy 2, to form tunnel between router 1 and router 2. So we can have multiple policies on a single router, right? But at least one policy should have same parameters. Right? Now guys, for the authentication I am using what keyword? Method pre-shared. So I will run this command here. Next command will be this one. In the global config mode, crypto, again crypto. All command will start with crypto, then ISAKMP, and after that I will define key. Key what? Let's say Cisco. And then I will define address. So address of my peer, right? 0.0.0. Form tunnel with any IP address, right? But if you will define any IP address over here, let's say 102.1.1.1, right? So it will authenticate 102.1.1.1 with what keyword? With what key? Cisco, right? And this key will be also guys encrypted with the help of number, with the help of key number, which router have negotiated with the help of Diffie-Hellman algorithm. So now hope this is clear to you, right? Now let's talk about the group. So we have, you know how many group? 1, 2, and 5. Always keep in mind higher number higher number means big random number. Higher number means big random number. So router, if you are using 1, right, so maybe it is using random number what, let's say 10. It is using random number what, 10. So if you will use group 2, maybe it will use higher number, let's say 10A. If you are using group 5, it will use higher number, let's say 10AB, like this, right? This is random number, and random number will be very complicated, right? Not like this. Okay, now guys, let's understand some packets of IPsec, then we will see the configuration. So R1, R2, both are connected through ISP. R1, R2, right? So first packet and second packet is used to exchange the policies, right? First router 1 will send what? First packet. This is first packet, P1. P1 means packet 1. In the packet 1, it will share their all encryption algorithm, hashing algorithm, authentication, group, lifetime, right? In the same way, router 2 will also send their policies. This is packet 2. And these two packets will be in plain text. In plain text, because now routers don't have any key. Now routers don't have any key. So these two packets will be in plain text. And these two packets are used for policies negotiation, right? Policy negotiation, right? Router 1 will share their policies that we have, you have configured on router number 1. In the same way, router 2 will share their policies to router number 1, what you have configured on router number 2. So packet 1 and packet 2 are used for policies negotiation. If both devices are using same policies, then only tunnel will work, right? So let's say on router number 1, we are using what encryption algorithm, 3DS, right? And on what hashing algorithm we are using, let's say MD5. What group we are using, let's say 5. What authentication method we are using, let's say pre-shared, right? What lifetime we are using, let's say 1000, right? So same thing should be configured on router number 2, right? Maybe we can have multiple policies, right? Let's say this on router number 1 we have multiple policies. This is policy 1, policy number 1, right? And I have one more policy over here, and in this policy I'm using encryption what, let's say AES. I'm using algorithm hashing algorithm what, Saha, right? I'm using group what, 1. I'm using authentication, let's say pre-share lifetime, right? This is what group number, let's say policy number 2. So when router 1 will receive a policy negotiation message from router number 2, router 1 will first check which policies, policy 1 lower value, right? But here algorithm will not match, so it will not negotiate the policy. Then it will check what, this number, this policies, right? Here policies will maybe match, then it will form the tunnel, right? So if we have multiple policies, it will check all one by one until match will not occur. We'll start from the lower number. We'll start from the lower number. So guys, what you can say, in first two packet policy negotiation take place. What you can say, in first two packet policy negotiation take place. Third and fourth packet. In third and fourth packet, we will exchange what? DH group, DH keys. DH key take place in third and fourth message. In third and fourth message, what will happen? DH key take place. Both router will share their random number first, then both will add one predefined number, then both device will add one random number, right? After that it will add the random number with predefined number and it will share with their neighbor, right, with the help of third message and fourth message. Router 1 will send third message, router 4 will send 4 message, right? Then both router will negotiate one key, right, symmetric key, right? So here in simple word, what you can say, packet 1 is used for policy negotiation, right? Packet 2 is also used for policy negotiation. Packet 3 is used for Diffie-Hellman key. Packet 4, Diffie-Hellman key, right? And these all packet will be in plain text, because till now after fourth packet both router will have one key, have one key. Now after fourth packet it is going to send encrypted packet, all encrypted packet, right? So with the help of packet, third packet and fourth packet, key exchange take place, right? So let's say I have router 1 here, again R1, R2, right? Both are connected through ISP. Let's say between it we have ISP. R1, R2, right? Let's say here we have what key, 100. Here also we will have same key, right, to encrypt the data. Now router 1 is going to send their policies, right, by encrypting them with the help of this key, both devices have this key, and this key is unknown for attacker, right? So now attacker cannot decrypt my data, right? Now attacker cannot decrypt the data, right? So you know how it will work. Let's say here I am using encryption key is, let's say what, encryption key is, let's say ABC, right? I'm using this key, ABC key, for encrypting the data, right? Algorithm is different, guys. This is key that I will use for encryption, right? And then let's say I'm using hashing algorithm, what, MD5, and what key I'm using for hashing, let's say XYZ, right? And now router 1 will encrypt it with the help of this key, 100 key, right? And then it will forward to router number 2. So think how secure it is now, right? So if you want to see what I can do, I can simply check the IPsec packet. This is website, IPsec packet, and you can say CloudShark. On the CloudShark website you can check the packets. So see, if I will open it, you can see the first packet. If I will open this first packet, you can see the messages. Layer 1, then we have what, layer 2, information, source MAC, destination MAC, then IPv4 code, then IP protocol, IP header, and then we have what, UDP. On UDP by default port number 500, right? We can use TCP port number 10,000 also, right? And then we have this actual message, right? Internet Security Association and Key Management Protocol, ISAKMP. So if I will open it, and if you will check the flag field, here you can see the flag field. If you will open it, you can see encryption, not encrypted. So this packet is in plain text. Anyone can read it. Attacker can read it, right? Attacker can read this information. Then we have payload. Right, so you can check detailed information. If I will discuss the messages over here, again it will take around 2 hours. Getting my point? So just see that first message is not encrypted message. It is in plain text. Second message, again if you will open second message, you can see second message is also not encrypted, plain text. But if you will open third message, again third message is not encrypted. Fourth message not encrypted, but fifth message encrypted, right? Because in third message and fourth message, it is both routers are going to exchange what? DH key. Both routers are going to generate one key with the help of Diffie-Hellman algorithm, and that key is unknown for attacker, and both devices will use that key to encrypt the algorithms, the policies, right? So no one can knows it. Getting my point? So third pack, fifth packet, sixth packet, rest, these all packets are encrypted, you can see over here, right? Okay, now next packet, packet 4, packet 1, packet 2, packet 3, packet 4 is hope clear to you. Packet 1 is used for packet 1, and packet 2 is used for policy negotiation, right? And it will send in plain text. Packet 3 and packet 4 is used to exchange key, to generate, you can say, symmetric key with the help of Diffie-Hellman algorithm, right? And Diffie-Hellman algorithm, guys, is a very important algorithm and very, very good algorithm, right? We are using it since long time, right? So if still we are using that, that means definitely there is something in this algorithm, in Diffie-Hellman algorithm, right? So with the help of Diffie-Hellman algorithm, both device will generate key, and let's say key on router number 1 is 100, router number 2 is 100, right? Now next packet, what about packet number 5 and packet number 6? So packet number 5 and packet number 6 is used for authentication. So here what key you have defined? Cisco. Here also what key you have defined? Let's say Cisco. You are using authentication method, what pre-shared. So you will define one key on both router, and both router is going to authenticate to each other with the help of which message? With the help of packet number 5 and packet 6. So you can say packet 5 and 6 is used for authentication, right? And guys, whatever packets we have discussed till now, these all are phase 1. These all are phase 1. Phase 1, right? Or what we can say, phase 1 means main mode. Main mode. Here also in the capturing, see, packet 1 main mode, main mode, main mode, main mode, main mode, main mode. So till packet number 6, these are main mode, or you can say we are saying it to phase 1. But packet number 7, quick mode. So as I told you, phase 1 is used to secure the path, right? So till packet number 6, we are using these all packets, packet 1 to packet 6, just to secure the path, right? And packet number 7 is using quick mode, that is phase 2. That is phase 2. And we are using phase 2 to encrypt the user data. To encrypt the user data. So phase 2 is quick mode. Phase 2, quick mode. Quick mode, right? So in quick mode means phase 2. Quick mode means phase 2. We are using quick mode or phase 2 to encrypt the user data. Quick mode is used for encrypt the user data, we can say. So now we have secure way to exchange phase 2 key or user data traffic. So DH is used, or Diffie-Hellman is used to generate a symmetric key over unsecure channel. Always keep in mind these things, guys. Again, these are important, right? So see, first router 1 will send packet number 1, right, to negotiate the policies. It will share their all policies, P1. Then router 2 will send packet number 2, right? In the packet 2, router 2 will share their all policies, parameters. Then router 1 will send what? Then router 1 will send group number that you have defined, DH. Router 2 will also send what? DH. Correct? In this DH message, it will send what value? The defined number plus random number, right? After that, both device will have this key, which is unknown for attacker, which is unknown for attacker, right? Then this is packet 4, P4, P3. After that, router 5 will send packet number 5 to authenticate router number 2. It will ask for this pre-shared key, right? Then router 2 will send packet number 6 to authenticate R1, and it is acknowledging as well with the help of packet number 6. So router 2 will not send any acknowledgement, but router 1 will send one acknowledgement as well, because first router 1 have sent the authentication message to router number 2, router number 2 have sent the authentication message to router number 1. Now router 1 have to inform. Router 2 don't need to inform because router 2 have just sent their authentication message after receiving the authentication message from router number 1. So only router 1 will send what? Acknowledgement. So this is packet number 7. This is packet number 7, right? And now we have one secure channel between router number 1 and router number 2. Through that we can forward user data. Through that we can forward user data. Now guys, to encrypt the user data, we are going to use one again protocol. That protocol is ESP. That protocol is called ESP. ESP stands for Encapsulation Security Payload. Encapsulation Security Payload, right? So we are going to use this protocol to encrypt the data, right? We can encrypt data in two modes. You know, we can, what I am saying, to encrypt user data, we are going to use this protocol, Encapsulation Security Payload. And we can encrypt the user data in two modes. Encapsulation Security Payload, right? It is used to encrypt user data, right? We can encrypt user data in two modes. First one is tunnel mode and second one is transport mode. Transport mode, right? So we are going to understand transport mode only, right? Now guys, let's move to configuration part, and while configuring I will make you understand some more concept. So here, see, this is my topology, because my god, okay, so this is my topology, and I'm going to access these devices R1. I will not access ISP because I have already configured the IP address on all devices, right? Only IP address is pre-configured. See, on router number 1, between router 1 and ISP, I'm using which network? 101.1.1.0/30. I'm using .1 on router side, .2 on ISP side. Between ISP and router 2, I'm using 102.1.1.1, sorry, 1.1.0/30. Again, I am using dot 1 on router side, dot 2 on ISP side. Router 1 is connected with one LAN where I'm running network 10.1.1.0/24. Router 2 is connected with one LAN where I'm running network 20.1.1.0/24. So on router number 1, see, so IP interface brief exclude unassign. This is IP configuration. And so IP route, let me check default route. So yes, default route is there, right? So interface, so IP interface brief. We don't have any tunnel interface over here, right? On router number 2 also, I've configured same IP interface brief exclude unassign. See IP configuration, and so IP route. I have one default route towards ISP, right? So on your edge router, first of all, you need to configure one default route towards ISP to make reachability between public IP address. Now let me verify both public IP addresses are reachable with each other or not. 102.1.1.1. I'm going to ping router 2 IP address from router 1. Yes, ping is working, right? That means there is public reachability. There is public reachability. Now here on router number 1, I'm going to create one tunnel. Configure T, let's say interface tunnel number 10, right? IP address 192.168.10.1.255.255.255.0. Tunnel source serial 2/0. Tunnel destination 102.1.1.2. This is GRE configuration. If you don't know the GRE configuration, watch my GRE video, guys. I have a separate playlist for VPN. You can learn GRE configuration, GRE tunnel, DM VPN there. We will do same thing on router number 2 also. So let me take you to router 2 now. Let me create one tunnel here. Interface tunnel 10. IP address over here is 192.168.10.2. 255.255.255.0. Tunnel source serial 2/0. Tunnel destination 101.1.1.1, right? Now let me verify the connectivity through tunnel. So ping 192.168.10.2. I'm going to ping this IP address from router number 1, and ping is not working. Ping is not working. I have to verify. So IP interface brief. So IP interface brief. So tunnel over here is up on router number 2. So IP interface brief. Tunnel interface is up here as well. So ping should work then. So IP route. Correct. So run interface tunnel 10. Correct. Correct. So run interface tunnel 10. Oh, here I have defined wrong IP address, right? So let me correct it. Interface tunnel 10 and tunnel destination 102.1.1.1. And now let me ping 192.168.10.2. Now you can see ping is working. Here I can run any routing protocol to exchange my private network. So let me run one routing protocol also. Let's say router EIGRP S number 10 network 192.168.10.0. No auto summary, and let me advertise my LAN network also 10.1.1.0. Correct. Now go to router number 2. On router number 2 also I am going to configure EIGRP. Router EIGRP S number 10 network 192.168.10.0. No auto summary, and let me advertise LAN network 20.1.1.0. So you can see we have EIGRP neighborship here, and we can verify the routing table. So IP route EIGRP. So I have learned 10 network, private network, right? On router number 1 also, so IP route EIGRP. I'm learning 20 network, right? So this is basic GRE configuration. Now my tunnel is not secure, right? First let me verify the connectivity between LAN to LAN. Ping 20.1.1.1, source 10.1.1.1. Ping is working. We don't have any problem. But you know what is problem? See, if I will capture this link, and if I will show you the traffic, My traffic is in plain text. Anyone can read it, right? EIGRP hello messages. Oops. Everything is in plain text. That means this tunnel is not secure. Now to secure it, I'm going to configure what? IPsec over here. So see guys, to configure IPsec, as I told you, first command that you will run is crypto ISAKMP and then policy. I'm going to create one policy over here. Let's say policy number is 1, or you can configure any policy number. Policy number is locally significant. So with the help of this command, see, first crypto, this command is saying I am going to configure cryptography. Then I am going to configure ISAKMP protocol, and I am creating one policy. Policy number what? 1, or policy number can be anything, 10, right? Here I will define encryption protocol and put question mark. See, Cisco supports these 3 encapsulation protocol, guys: DS, 3DS and AES. So whatever protocol you want to use here, you can use, but as I told you, generally we are using what? AES, right? Then I'm going to define authentication method. What authentication method you want to use? So see, if you want to define key manually, you will use pre-shared, right? Otherwise you can use this method also: RSA encryption, RSA signature, right? If you don't know what is RSA encryption or RSA signature, so guys, what you can do, you can request me to make one video on it in the comment section. Definitely I will make one video on it, right? Leave it for now. For now I am going to use pre-shared here. So authentication method that I am using over here is pre-shared. Then I have defined the encryption, I have defined the authentication, then hashing. What hashing algorithm you want to use? MD5, SAHA, SAH 256, SAH 384 and SAH 512, supported by this router, right? So for now I am going to use MD5 here, right, as a hashing algorithm. Then I will define what lifetime. Let's say lifetime is 1000, means after 1000 seconds it will refresh the key, right? And then let me define the group, right? So you can see these group we have here, right? Let me say 1. This is which group? Diffie-Hellman group. This is predefined number, right? And it will pick one random number. With the help of that, it both device first will add their random number and predefined number, then it will share with each other, and then both device will generate one unique symmetric key, and it will use to encrypt these algorithm which we have defined over here. Do so history. See the configuration. This is configuration. Crypto ISAKMP policy 10, encryption AES, authentication pre-shared, hashing MD5, lifetime 1000 and group 5. I will do same configuration on router number 2 also, but before that, as you know, if I am using authentication pre-shared, then I have to define key over here, right? I have to define key here. So I am going to run one more command here, crypto and then ISAKMP key is, let's say what? Cisco. Key is Cisco, and then you can define address. If I am defining address 0.0.0, it can negotiate tunneling with any router, but here you can define the peer IP address for security. So peer IP address is 102.1.1.2, right? Then that's it. This is phase 1 configuration. This is phase 1 configuration. Right? We can verify it by running command so crypto and then IPsec and put the question mark policy. See, here we are not able to see any policy now. Here we can say key. So crypto, sorry, ISAKMP and then policy. So you see what hashing algorithm you are using, MD5. What authentication method you are using, pre-shared. Diffie-Hellman group 1, lifetime 1000, right? Then we can check key. What key I am using? This. For width, peer device 102.1.1.2. This is IP address of router 2. Then what we can check here, security association. Now we are not able to see any security association over here. One tunnel will come up, you will see security association as well, right? Okay, then profile. No. So this is guys phase 1 configuration, right? Now let's configure phase 2. Phase 2 means to encrypt the user data, right? And as I told you, to encrypt the data, we are going to use which protocol? ES protocol. We are going to use encryption security payload, ESP protocol, right? And to encrypt the data, we have two mode, tunnel mode and transport mode. Which mode we are going to use here? Transport mode, right? So let me run this command again, crypto, because I am going to configure cryptography, then say IPsec, and after that mode, transport set. Then here you have to define the name of your transport set. So let's say transport set name is PM, and then ESP. What encryption algorithm you are going to use? 3DS. Again ESP. What algorithm you are going to use for hashing? MD5 HMAC. HMAC stands for hash based message authentication code. It is a cryptography authentication. I am talking about this value, right? Hash base message authentication code, right? It is a cryptography authentication technique that uses a hash function and a secret code, you can say, right? So I'm going to hit enter over here. So this is phase 2 configuration, guys. This is phase 2 configuration. Now phase 2 configuration is also done. And then mode. Which mode I am going to use? Again, if you will put question mark here, you can see you are getting two mode, transport mode and tunnel mode. So I am going to use transport mode, right? This is phase 2 configuration. Phase 2 configuration is done. Now problem is what? Problem still we have one problem. You know, we cannot apply it directly on the interface, right? So I want to apply this on the tunnel interface, but I can't apply it directly. So what I have to do, I have to create one profile here, right? So if you know the profile configuration, guys, how to create profile, this thing, it's easy for you. If again don't know, you can let me know, right? I will make one video on it. Okay, so to create the profile, what command I will run again? Crypto IPsec profile, IPsec profile, and then profile name, let's say PM. Again this name is locally significant, and then set transform set PM. That's it. Now with the help of this profile, I can apply it on the tunnel interface. So let me apply it on tunnel interface. Interface tunnel 10, and I am going to say what? Tunnel protection IPsec profile, and then I will call to my profile, that is PM. See, tunnel will goes down. Now you can see tunnel is down, right? Now ping will not work. Ping 20.1.1.1, source 10.1.1.1, right? See, ping is not working. Okay, so I have to do same configuration on router number 2 also. So let me configure everything on router 2 also. First is crypto. First of all, I need to create one ISAKMP policy. So crypto ISAKMP policy number, let's say 1. On router number 1, I am using policy 10. Here I can use policy 1 as well, right? Then authentication, pre-shared. Then encryption algorithm. What encryption algorithm I have used on router number 1? AES. So here also I have to use AES. And let me verify it on router number 1, because this is very important. So crypto ISAKMP policy. So for the encryption, we are not able to see here. What I can do, so run and section, let's say crypto. Yes, encryption, yes. So here also I have used what, yes. So both side encryption algorithm should be same and hashing algorithm should be same. So hashing algorithm here also should be MD5. Then lifetime 1000. If you will not define lifetime, so minimum value will be negotiated. And then group. What group number I am using on auto number 1. So here also I will use 1, right? Then I need to define pre-shared key. So say crypto ISAKMP key Cisco address 101.1.1.1, right? Now I cannot apply it. Sorry, this is phase 1 configuration. Now let's configure phase 2. Crypto IPsec transform set. Transform set is phase 2 configuration, quick mode, right? Quick mode. So crypto IPsec transform set, and then if you will put question mark over here, what option you are getting? Name of your transform. So let me say PM over here as well. PM, and then ESP. What algorithm you are using for encryption? 3DS and ESP. This is ESP is what? ESP is encapsulation security protocol, which is used to encrypt user data. And here I am using encryption algorithm what 3DS, and then I am going to say MD5 HMAC. Fine. Then mode transport. Now I cannot apply it on interface directly. So what I need to do? I need to create one profile here, right? So to create profile, you will run command crypto IPsec profile, and profile name PM. Right, guys, in the configuration I am going slowly so that you can catch it. Crypto IPsec profile, and then profile name. This is profile name is locally significant. Then set transform set, and then name PM. I've created the profile. Now I am going to call this profile on tunnel interface tunnel 10, and tunnel protection IPsec profile and name of profile. Now tunnel interface will come up. It's filled with the PR at 101.1.1.1. So there is some misconfiguration. Let me do one thing. So run section crypto. So here encryption policy, this one number 1 has MD5 authentication piece here, life 1000, key is Cisco, and key on router number 1 is what? So run section crypto. Here also key is same Cisco. Oh, problem is what, guys? Here you can see the address will be 102.1.1.1, right? So let me do one thing. Let me remove this command, say no to this, and then I am going to say crypto ISAKMP key Cisco address 102.1.1.1. Now tunnel will come up. Yes, now you can see. Wait for some time. So crypto ISAKMP SA. Yes, now you can see we have one tunnel, right? On router number 1 also. So you can see again EIGRP neighborship has come up. So crypto ISAKMP SA. Yes, we have tunnel, right? Secure tunnel. Now if I will ping to 20.1.1.1 and source 10.1.1.1, let's say repeat 1000, and now guys see the capturing. Now you can see these messages. These messages are encrypted, right? Now no one can read it. See, this message is encrypted. Encapsulating security payload, right? Now you can see the message, right? So this is IPsec configuration, and now your tunnel is secure. Now no one can read your data on the tunnel interface, right? So hope IPsec is clear to you now, guys, the basic. If you have any question, right, any doubt, please let me know in the comment section. Definitely I will make one another video. And if you want to learn, guys, these all things in detail, you have to take live training from us, right, or from any other institute as well, right? Because this is not like one day class. IPsec is not one day class, right? Minimum it is 20 to 25 hours contents, right? So I cannot cover it in a single video, but I try to cover many things. Hope those things is clear to you, guys. Now if you have learned something from this video, please hit on like button. If you have not subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. If you are looking for any paid course, please check the description. Please visit to our website and see when next live batch is starting. Like if you are looking for SD-WAN, so check when next SD-WAN batch is starting, right? And if you are interested, if you are looking for any paid course, you can enroll yourself there. Thank you. Thanks for watching. Bye bye.